So this video is primarily supposed to be about hierarchical or multi-level. Those words I'm going to use interchangeably, but hierarchical or multi-level indexing using the zip code data that I scraped off the internet. Hopefully by the end of this, you'll see the usefulness of using hierarchical indexing and for any kind of sort of data that's greater than 3. So for the most part, when you're looking at a matrix, you know there's rows and columns. And now I want to be able to go even maybe in a tensor level to deal with data. In other words, I want dimensions maybe greater than 2. So hopefully by the end of this, you get that. Now I've already ran, you can kind of see down here, I've already ran this first, I don't know, 5-6 lines of code. And all it did was it brought in the zip code data that I scraped off the internet. So let's check it out real quick. And so you can see it's zip, and the zip is not correct right now because obviously there's not 3 numbers in a zip code. I believe that should be 00601. And then over here you will see we calculated area, and the way that we calculated area is just a simple, if density is equal to population divided by area, then area must be population divided by density. Just a simple little calculation here to sort of get us. And I added 1 on there just because there were some zeros running around and I wanted it to be an infinite number. And then you guys can check this out yourself. So feel free to stop the video, type this stuff in, run it, and then just pull up the data. A lot of times you want to get familiar with the data, and there's many more columns than maybe what we've used in the past. And you can see the cities and the state names and the population. So there's in density, and there's information in there. This county FIPS is a unique identifier for the county name, but I'm just going to use county name. Okay, so that's the data. That's where we're sitting at right now. Let's do some things to make this data a little bit better. So I'm going to call this format zips. We want to return. Let's see, we want it to be format. Oh, I need to put in an X, so we're going to bring in X, zip, the name, sure. Yep, it is, zip over there. So I'm going to format.zip by doing this, by passing in 0.5, not dot, I don't want any decimals. So 0 is the padding, the right is to move everything over to the right. If I did the left, then those would be the first 3 numbers. I know they're not the first 3 numbers. I want to put the 0, 0 in front. So that's why I got that right or greater than sign there. And then 5 is the number of spaces that I want. So this is going to pass back a string that's going to give us something that we're interested in, or something that's going to reformat those zip codes. So let's now apply that. So zip codes, zip to zip codes, oops, zip codes dot apply, because I'm passing in every single row, and I want it to be format zips and axis 1, because we want to do it for every single row, so we're looking down the column. And so let's bring up zip codes again, and hopefully now we have a string that has the 2 zeros in the front. And let me just go down a little bit for, oh yeah, so it has a 0 in the front. Okay, so we're good there. All right, let's look at right now our zip codes dot index. If you remember, that's the row. So it goes from 0 to 33,000. So there's 33,099 zip codes in the United States, including Puerto Rico. And zip codes dot columns. Can't spell. And that will be all the column names. So we have zip, lat, long, city, state ID, and so on and so forth. So we have all those. I just wanted to get those out there because we're going to change We're going to do some stuff here. The first thing that I'm going to do is, I don't know, let's calculate, and this looks like, right? So I'm taking the population. So remember pivot table from last class or last video. We're going to take the population. That's the thing we're going to do the ag function on. So here's the ag function sum. So we're going to summarize for every state, and then we're going to sort it. So if I just ran this without the sort by, it's just going to give me the state in alphabetical order. So we did that. So that's really the first thing that I would do if I was going to, in my mind, hey, I want to now take all of this data and I want to use it to find the state populations. That's the first thing that I would do. And then if I wanted to look at it by which one was the largest, then I would run this whole thing. So now you can come up here and see it's sorted by how we want it to be sorted, and that's what that's doing. Not really big, not a hierarchical thing. So I just wanted to show you another example of a pivot table. And so the next thing that we want to do, so I would, again, if I were running this, the very first thing I did when I was calculating this was actually run this. So what this thing is doing is it's going to go to zip codes, and it's going to look at the state name, and it's going to see if the state name is equal to Alabama, then this will be a Boolean Boolean mask. And then I'm going to pass this Boolean mask into the zip code so that it gives me a data frame. So now I have only the 642 zip codes that are in the state of Alabama, and there they are. There's the first 5 of them and the last 5 of them, and then all of the other information. This ... just means it has a whole bunch more information, and we're not showing you everything. So now I would take this and pass that in, so you can see the dot pivot table. So I'm passing that in again. I'm summing, right? So the ag function is summing. I'm summing by population. I want my index to be city, and I want my column names to be county. So if I wanted to sort of visualize this thing, I could maybe run it like this. And if you pull this up, you see a whole bunch of zeros, and then every now and then a number, right? So Alexandria is in Calhoun County. If you went to the bottom, you see all of the population in Calhoun County. You see the population in Butler County. Move over Jefferson. Let's see where Jefferson is the largest, I believe, in the largest county. There it is. So Jefferson, 660,000, has Birmingham in it, but Birmingham actually straddles two counties. So that's a weird thing about Birmingham. The city of Birmingham is in 2 counties. It's taking me forever. I apologize. There we are, Birmingham, and then I believe it's in Shelby County. Nope. There it is, Shelby County. So it has 50,000 people in Shelby County, but most of its population is in Jefferson County. Okay, so that is a big old giant table with a whole bunch of zeros. And if you did the calculation on this, this is 526 by 68. Just for the population, it just seems like, and if I do the math on that, let me get my calculator over here, 62. So it'd be 35,768 pieces of data, including all that sparse matrix, all these zeros that are included in there. The thing is, I think we can do better. So I think we can do better using hierarchical data. You might be used to looking at it in sort of this idea of a spreadsheet, but we can look at it in hierarchical data. So I'm going to so this is only a 2-dimensional deal here. So I'm going to copy this thing again, Control C. Copy it down here. I'm not going to call it, I'm going to call this just state counties. And we'll leave Alabama in there just for right now. Let's see, zip codes, all of that looks right. Pivot table. We still want to do population, but instead of doing this business, I'm going to take out the columns for a second. I'm going to do multi-level indexing. So what does that mean? I got to put in 2 indices here. So the first one is going to be, so you got to think about this for a second, right? So I got a county and then a whole bunch of cities that go along in that county. So that's what name, comma, city name. And then fill NA, there won't be any fill NAs, except there might be some things that we want to drop. So if there's no 0 in there, I just want to drop it. So drop NA is what we want to do now. And then let's highlight this copy, or let's highlight that and hit go. And then let's see what we have. Okay. So in this case, I only have, so index is the county and the city. And so for example, so you still have to kind of go around and find Birmingham if you're interested in Birmingham. So there was 2 counties, Shelby and Jefferson. So Jefferson, Birmingham, there it is. And then Shelby, Birmingham. So Shelby County has Birmingham. Okay. Unfortunately, so when you're doing this thing, unfortunately, accessing the data is a little different than what Vanderplas had in his book, and so I want to show you a couple things. And I think maybe it's because we named it, because I have an index called named county name and county seat, but I just want to show you how you can actually do this. So there's ways that it can do it. Controls. So that was going to be my first line there, right? So I wanted to access this. I believe this one works. V F9. So that works. So if I want to, if you use the dot location dot loc, and it's the first level of your indexing. Oh, let's do this too. State keys dot index. So now you can see it's a multi-level. So multi-index, the county, and then the city, and so on and so forth. So if you, I can go and erase that. I just wanted to show you guys that what is a multi-level index. And then we did Mobile. So Mobile has all these cities in it. The problem though is if I wanted just a city, right? So for example, what if I wanted Mobile or Birmingham? Birmingham is not the name of a county, so you get this business. All right, so that stinks. And so you might be thinking, well, maybe I can come in here. Maybe that's how you do it. Nope. According to the video, that's what it looked like is all you needed to do. But that is not the case. Maybe maybe you put in like this. I'm going to do Mobile, comma, Mobile. I think this works, Mobile. But this is kind of hard to mess around. No, this doesn't work either. So, oh, dot lock, dot location. That would work. Okay. Again, this is not very user friendly. What if I wanted all of the name of the cities that yeah, anyways, in other words, what if there are multiple cities in different counties that I wanted to go get, right? And this just isn't helpful. In other words, you have to know the county that's in order to access the city. So that's not good. So let's do this. Let's state counties dot query is one way of accessing the data. And if I did a query where city is really equal to, oops, you got to put a single Birmingham and then end it. And you'll see, then you get the data that you're looking for. So you can see that Birmingham has 2 counties. Let's see, let's do the same thing. Control C, Control V. Now you can do maybe county name is equal to and now you get the same stuff that we had got up here when we just used dot lock Mobile or dot location Mobile. So fortunately for us, there is another way to access this cross. It's called a cross section, right? So that's why it's XS, cross section, for multi-level hierarchical indexing. All right, so let's go about doing that. So state counties dot XS. And what does that look like? So XS, so let's do Mobile since it has multiple levels. So let's do Mobile, and let's go with level equals 0. I think we should get the same thing that we had got before, and we do. So in this case, you're doing cross level, and what does the level 0 mean? It just means, I should have left it up here. Counties dot index. So what it's saying is that this is level 0 and this was level 1. So level 0 is give me the county name where it's equal to Mobile. And if I do a level 1 here, then it's going to give me the city name where it's equal to Mobile. So that's helpful. And then, yeah, I think that's Birmingham. And now you get the two counties that it's in. All right, so let's look at a three-dimensional case. I'm going to grab this, Control C. I just don't want to type in this entire thing again. And we're going to call this county cities. And we're going to set that equal to the zip code business, but I'm going to take this part out. And we're just going to start off with a pivot table. And then I'm going to let, instead of telling it population, I'm going to grab two things this time. So I'm going to take out population here, and I'll show you where you can put the things that you want to aggregate on. We're going to start off with state. I think it's state name. Make sure that's true before we go. Zip codes. State underscore name. Okay, so that's good. So state name is an index, county name is an index, and city is an index. Because I want the state to be the highest level, and then county to be the next level, and then the city to be the next level. All right, so then we can come back and do ag function. And I don't know, do I want margins? I don't necessarily want margins to be true. Ag function. So here's where we're going to tell it what we want. So inside, I'm going to put a dictionary in here. And what you do is you tell it the column that you want to do as the key in the ag function. So in this case, we're going to let population, and then we'll do the sum, and then comma, and then the next one would be, I think area was the one I wanted. So area also to be sum. And if you want to get real fancy, you can maybe do densities, the mean. It doesn't matter. But just understand that this is the field. I mean, the only reason I'm doing this is to show you guys how to do it, right? So just to know that this functionality is out there. If you want to do different things to different fields, I don't know, we'll put mean here. Obviously, that's not going to really mean a whole lot, but it'll give you the average area. But we can't use it for any calculations because it doesn't really think about what that really means. Let's see, and then we want to drop in a, it's fine. Okay, so I think that's what we want to run. Let's run it real quick. And now we want to access data. So this is sort of a three-dimensional. Let's look at it real quick. So county cities has three dimensions to it. So it has a state, a county, and a city. And now we can go, let's do some things that I think that we live in Orange County, New York here in West Point. So let's look at, so county, cities. Let's do a state first, Alabama. Actually, New York, I like New York. New York. Then level equals 0. Let's see what that gives us. Yeah, it didn't like that. Is that how we do it? Oh, .xs. Still didn't like that. Did I mess that up? Level equals 0. XS. Invalid syntax. Let me make sure. Oh, it's parenthesis. So in this case, we get New York and level equals 0. So think about what level equals 0. That was the state. Remember, that's the, so if I'd looked at Control C, Control V dot index, and it just gives you all 27,752. But at the end down here, it gives you the levels. So the first level is state, the second level, or level 0 is state, level 1 is county, level 2 is city. So then you can come back and say, give me all the New York. So there's only one county called New York. And then, let's see, level 2 is the city. So state name, county name, and then you know what the city name is because you just gave it. How about, what if we did orange? I want to look at all the orange counties in the country. So remember, level tells me the county. That's what I want to do. So 0, 1. 1 would be county. So let's look at all the counties that have orange in them. So California has 1, 2, 3, 4, 5 cities in Orange County. So what this is giving you is giving you all the states and all the cities that are in Orange County. So California, Virginia. So if you want to know all the states, no, it wouldn't. How about level 2? So in this case, these are all of the state and counties that have orange as a city. So Orange County, California has Orange City. Orange or New Haven, Connecticut has an Orange City, and Franklin, Massachusetts. What if you wanted to pass in more than one? For example, county, city, XS. Suppose I want to know all the orange. So in other words, I'm just going to grab the Texas and the California, where the county name and the city name are both orange. Orange, comma. So I'm passing 2 levels into this orange. And I'm passing 2 levels into here. So I got to say level and 2. And so in this case, there's only 2 states that have an orange county in an orange city and an orange county in a state, and they're California and Texas. So there's a lot of things you can do with XS. I mean, cross sectioning. Just understand that that's out there, and you might have to mess around with it in order to really understand what's going on. The last thing that I want, before we do that, let's do one more thing. So county, here, let me just copy this one. Control C, orange, and then maybe, let's do a query. What if I wanted a query where area is greater than 300? I don't know if that's a big area or not. Let's see if that works. There's 4,150 that are greater than 300. How about 500? How about 1,000? I'm trying to make it so that it prints it all off. All right, so it printed it all off here. So you can see that you can do queries on really anything. You can look inside the index, you can look inside the area, right? So in this case, it queried off all the guys in there. You can use population. You can also, and I don't think maybe I have or have not talked about this, but you can do this here. Let's go with area 1,000, and then county dot query area is greater than, and @ area. Close this off, sorry. Undefined variable. Oh, did I not run it? Okay. I was kind of hoping that would work. So if you want some kind of variable inside your query, you can do this. You can define the variable and then use the @ symbol in order to do it. Hopefully it works in this other one as well. Let's see. Let's do one more to make sure that's true. I don't know if this will work. We're about to find out. Let's go city no, county name is really equal to at. I'm going to define CTY is equal to, oh, it does work. Okay, I was just making sure that the string didn't kind of mess that up a little bit, but it does. All right, so I'm pretty excited about that. All right, the last thing I wanted to do is to show you some things that you could possibly do with you know, with the data frame. So in this case, I have students, and I'm going to create this data frame called students, and let's bring it up so you guys can see what it looks like. So it's just this simple data frame. It has people's first names, has people's zip code, and has maybe the course that they're in. So what I'm going to do is I'm going to use that zip code data, and I'm going to snag all the lat longs for these zip codes. So the next thing that we do is city, state, lat, long is equal to, and I'm just going to merge these things in and grab all the lat longs, and hopefully it did what we wanted to do. So again, you can see first name, zip code, course, city, state, I think, oh yes, oh, so check out what it did. It grabbed the city, and it grabbed the state, and it grabbed the latitude, and it grabbed the longitude. So that's pretty, I don't know, I think that's pretty neat. I can go in, if I got this this master database that has information in it, and all I'm doing is I'm tagging 31733 to that zip code data, then it just comes in and it grabs the city, the state, the lat, long. I could grab the population. I could get anything out of that thing and attach it to my my students' data frame. And now what I want to do is create this function. Now I had to look this up. I didn't know what this horizontal function was. That's why I sort of documented it here. I haven't really done the math on it. It looks sort of okay, like it's not that big a deal. But I think this is all I'm trying to do here is calculate the point, not the road distance, but the point distance from anywhere, any lat long. And so that's what this thing does. And so all you do is you pass x in, and as long as x has a lat and a long in it, it's gonna. Oh, and you got to also do this as a global variable. So what I did was I went in and grabbed West Point's lat long from zip codes data, 10996, and then now I'm going to calculate all of the distances from my students to their hometown. So there's their hometown, and these are the lat longs, and so this thing will use that in order to calculate this distance. Again, this function can be anything you want it to do, right? So all I'm doing is I'm applying this function and x is equal to 0 means look down, you know, by column you're going to do it, and then pull up where students at. There it is. And then now we're going to look at, hopefully has a distance home, right? And so if you just did the lat long calculation to Georgia from West Point, 858, and I think the last thing, let me make sure, yeah, converted to miles. So this would be miles to Houston from my hometown, or Didor, Alabama, 1,000, and that's about right. I think it's 1,200 if you do it by car, and then 999. Anyway, so that's all I got. Hopefully you got something out of this one, and we'll see you next time.